Hello, my dear children. Welcome back to the physics class. In today's class, we are going to learn the chapter Light, Reflection and Refraction. Today, we are going to learn about light and its properties, reflection, its images, mirror and its types, ray diagram of mirrors, use of mirrors, sign convention and mirror formula. Now, let us see about the what is light and let us learn about its property. As we all know, children, light is a form of energy with which we are able to see the things or the objects surrounding us. So it enables us to see the objects, isn't it? Wherever the light falls on an object, the reflected light will enter our retina and it will make the things to be visible to us. That means, in the absence of light, we cannot be able to see any of the objects. Let us see the properties of light now. The first property says light is an electromagnetic wave and it does not require any medium. That means even the light can travel in vacuum. Light tends to travel in a straight line. That explains the rectilinear property of light. Always the light will travel in a straight line. And the third property says it has a dual nature. That means light will act as a particle as well as a wave. Light casts shadow. If you just think any of the light sources, like a candle, just observe the candle, children. When you light up the candle, just opposite to that candle, you can observe the shadow of the candle, isn't it? So that means the light sources will cast shadows. Speed of light in vacuum is 3 into 10 to the power 8 meter per second. Even this value is applicable for the speed of light in air. When light falls on a surface, then two things can happen. Either it might be reflection or refraction. It depends on the type of the surface. If the surface is a polished surface, then the light will falls on the surface and it gets reflected back to the same medium. That means it is called as a reflection. Whereas if the surface is a transparent medium, then the light can penetrate through that medium. Therefore, so the light wherever it falls on the transparent medium, then it bends to the different medium. That is called as refraction. In today's class, we are mainly concentrating on the topic that is reflection. Now, let us see what is reflection of light. When light bounces back after strikes a polished surface, we call this phenomenon as reflection of light. So already you have studied the laws of reflection starting from 8th standard, isn't it? So what are those laws, children? So according to the picture what I have here, so here I have a plane mirror and a ray of light is incidenting on the plane of mirror, and normal is a line which is perpendicular to the plane of mirror, and the ray gets reflected and that ray is known as the reflected ray. Remember, incident ray and the reflected ray makes an angle with the normal. So that angle we call it as, with respect to the incident ray we call it as angle of incidence, and with respect to the reflected ray we call it as angle of reflection. So therefore the laws goes like this: angle of incidence is equal to angle of reflection. The incident ray, reflected ray and the normal at the point of incidence all lie in the same plane. So that is, so when I say angle I is equal to angle R, that is nothing but the angle of incidence is equal to angle of reflection. So remember, the reflection of light takes place only when the surface is a polished surface. Okay, that too we are talking about a plane mirror. Therefore, whatever the reflection that takes place in the plane mirror, always it obeys the laws of reflection. Now, let us see about the image formation. It is a point when do we say that the image has been formed. So, we have a criteria here, children. It is a point where at least two light rays actually meet or appear to meet. Wherever the two light rays actually meet or appear to meet, then we say that image has been formed because of the light source. Then there are two types of images. when we talk about the real image and virtual image. Now let us see about the characteristics of real image. It formed when the light rays actually meet. That means the real images can be caught on the screen. And remember, always the real images are inverted images. Whereas the virtual image cannot be caught on the screen. That means though the lights get reflected and these light rays will appear to meet, they actually don't meet, they will appear to meet at some point. Therefore, so we can say that the virtual images are not obtained on the screen and they are always erect. Now, let us see the image formation on a plane mirror. So, almost all of us have a mirror at home, isn't it? So, you just try it over there. Here, I have a plane mirror, and the surface, the polished surface, is towards my left side, and the right surface, left side is a reflecting surface, and the polished surface is towards the right hand side. Now, if I consider the object towards the left side, okay, then if I just pass a source of light from this object, if I just cast a light on this object, then it forms a light rays will pass through the object and it will fall on the reflecting surface of the plane mirror. Then what is going to happen now, children? So the plane mirror will reflect the light in the same direction, so it is going back in the same line, isn't it? Now what I'll do is I'll just take a point in the mid of the where the plane surface is making the point on the plane mirror. I'll just take a line over there towards the height of the object, and then I'll just extend that according to the laws of reflection. So the angle of incidence makes an angle I. If I consider this line is to be the normal, then angle of incidence should be equal to the angle of reflection according to that condition. So I have drawn the angle of incidence and angle of reflection. Now if you just extend the point where the reflected ray is going out, then it is appear to meet at a point. Say even this angle of reflected ray, when it is extended to the other side, then both are going to meet at a point. That point will make, just observe children, here these two points are not meeting at a point, but they appear to meet at a point. So therefore we call this type of images as the virtual image and erect image. The image formed here is a virtual and erect image. And what about the object and the image formation? So just observe, the image formed is exactly equal to the object. And what about the distance of the object and the image? If I consider that object is at 1 meter from that of the plane mirror, then exactly at 1 meter behind the mirror the image is formed. Now the last point says that is laterally inverted. Then what do you mean by laterally inverted? Let us just think it over or understand that with another slide. Here I have a lateral inversion. That means the left will look like right and right will look like the left. So that is apparent reversal of the mirror images left and right when compared with the object. If I just consider this as a plane mirror, and if I have written green board in a reverse order, and if I just look at the mirror, then it appears to be green board. Okay. For like example, where do we find this application? We can find this application in the ambulance. So usually ambulance letters will be written in the reverse order, so that whenever this is appeared on the plane mirror of the vehicle, then they can clearly observe the spellings of ambulance in the correct way. So this is about the lateral inversion. Now let us know about some of the spherical mirrors. Spherical mirrors are the mirrors which is a part of a sphere. If I consider this one pink with the blue color shaded part, this is a spherical mirror. Spherical mirror is a part of a sphere. So where the one side of the mirror is been polished and the other side is the reflecting surface. And if I consider the midpoint of the spherical mirror, that can be called as a pole of the mirror. And we have another that is represented with the capital C as a center of curvature. If I extend this spherical mirror, it is going to form a sphere. And when I say sphere, it is just like a circle. When I say circle, it is a two-dimensional figure. When I say sphere, it is a solid. And almost we have a concept that for every solid, like a sphere, it has a center. Okay. So like if I consider this whole part to be a sphere, then we have a center for the sphere. That center is called as a center of curvature. And remember, the distance of the pole of the mirror with the center of curvature is known as a radius of curvature. And also I have a capital F, which is called as a principal focus. And principal focus is a point where it is just exactly the midpoint between the center of curvature and the pole of the mirror. And also remember, this is the point where most of the images are going to be focused. Therefore, it is named as principal focus. And remember, F is a midpoint. And we have the next phenomena, that is a focus length, or it is also called as a focal length. So focal length is nothing but it is the distance of the principal focus from the pole of the mirror, and it is going to be represented with a small letter f. And the last we have, that is aperture. Aperture, it is indicated with the letters capital M and N. Aperture is the effective diameter. Aperture is a effective diameter of the spherical mirror. So that means it is a distance between the M and N, the effective diameter of the spherical mirror or the reflecting surface. We call that as a aperture. And also we have one more line which is called as a principal axis. Principal axis is an imaginary line which has the center of curvature, pole of the mirror and the principal focus on it. We call that as a principal axis. So these are the terminologies we are going to use further, children. So this is all the basic thing. P is the pole, which is the center of the spherical mirror, and C is the center of curvature, which is the center of the whole part of a sphere. Radius is nothing but it is the distance of the pole of the mirror with the center of curvature, and principal focus is a point which is exactly the midpoint between the pole of the mirror and center of curvature, and also a point where most of the images are going to be focused. Focal length is the distance of the pole of the mirror with the principal focus, and aperture is the effective diameter between the reflecting surface of a spherical mirror, and principal axis is an imaginary line which is having the center of curvature, pole of the mirror and the principal focus which is lying on that axis. That axis is known as a principal axis. So I hope you have understood all these, children. And at last we have a relationship between the radius of curvature with that of the principal focus, focal length. So that is, radius of the curvature is exactly twice of the focal length. So that is r is equal to 2f. It is very important. So children, this relation we are going to use further for numerical problems. So remember this formula, r is equal to 2f, where r is the radius of curvature, f is a focal length. Now we are going to learn about the spherical mirror whose reflecting surface is a curved one. And remember, only one surface is a reflecting and the other surface is a polished. Here we have two types. One is convex mirror, the other one is concave mirror. Convex mirror is a mirror in which the reflecting surface is curved outward, whereas concave mirror, the reflecting surface is curved inward. And the second point says convex mirrors are diverging mirrors, whereas concave mirrors are converging mirrors. Now let us learn about these spherical mirrors. Now let us first take up the rules to make a ray diagram by concave mirror. Usually we have four rules, children. The very first rule says a ray parallel to the principal axis. Which is the principal axis? Axis which has the center of curvature, then principal focus and the pole of a mirror. So a ray which is parallel to the principal axis wherever it passes through the focus after reflection. So wherever you draw a line parallel to the principal axis, always it gets reflected back. So pointing or it passes through the principal focus. So this is the condition. So if I draw a line towards downward, then it also will pass through the principal focus. This is the first rule. And the second rule says a ray incident through the focus. Wherever a ray is incident through the principal focus, then the reflected light will pass parallel to the principal axis. This is the second rule, children. And the third rule says a ray passes through the center of curvature, it is reflected back on the same path. That means wherever you draw a line which is passing through the center of curvature, both the incident ray and the reflected ray will be on the same line. Okay, this is the third rule. And the fourth rule says wherever a ray is incident on the pole of the reflecting surface, then the reflected will make an angle which is equal to the incident ray. That is, you have to apply the second law of the law of reflection, that is angle of incidence is equal to angle of reflection. Okay, these are the four rules, children. We have to keep all these four rules in order to draw the ray diagrams with respect to the concave mirror. Now shall we start the ray diagram, children? Yes. So here I have the first point. Here we have 6 cases, children. In that the first case is when the object is at infinity. Here I have a concave mirror, that means the reflecting surface is inward and the polished surface is outward. Okay, and here wherever you draw the ray diagram, you need to indicate the image, how where the image is situated, that is its position, nature of the image, size of the image. So this is known as the nature of the images. So whether position, nature, size. Along with the ray diagram, if you write this, then so it is very, very important. Usually they'll ask this type of question in the exam, children, for 3 marks. So be attentive and carefully listen the things which are what I am going to explain now. Now the very first case is when the object is at infinity. So suppose somewhere the object is at, and now the light rays are coming from there and it is falling on the reflecting surface of a concave mirror. Then according to the first rule what we have studied, wherever the light ray is parallel to the principal axis, then where it has to pass through? Of course, yes, it is from the principal focus. Therefore, all the light rays will pass through the principal focus. And remember, as I've said, wherever the two light rays after reflection meet, that is going to be the image formation. Now, where the light rays are being merged now? Yes, if it is at the principal focus. Therefore, the position of the image is at F, where it is principal focus. What about the nature of the image? It is real and inverted. And what about the size? Size is a point size. So it is very difficult to recognize the image formation. So therefore we call it as it is highly diminished image. Therefore it is called as a point size image. So I can say the light rays are coming from infinity and they are merged at the principal focus. And the second case here is the object is placed beyond C. So when the object is placed beyond C, now let us see the image formation. As I have said, remember the light ray has to first pass parallel to the principal uh, axis. Therefore, a light ray will pass through the principal axis. The next condition is, so wherever it is parallel, it has to pass through the principal focus. Before that, one of the light ray has to pass through the center of curvature, that is a compulsory point here. Okay, so this line where the object is passing through the center of curvature. So remember, both the incident ray and the reflected ray will pass on the same line. Now I have to apply the first rule. According to that, the reflected light ray will pass through the principal focus. Remember, the earlier reflected ray and the line which is passing through the center of curvature, both are meeting at a point. Therefore, it is going to form a image. So that is, the image is like inverted. What about the size of the image? The size of the image is smaller when compared to the object. What about the nature? Nature is the image is real because it can be caught on the screen, but it is inverted. What about the position of the image? The image is formed between F and C. So this is the nature of the images you need to write for the second case, children. Now, so we have a third case when the object is at C. Okay, what is the first condition? The line has to, or the ray has to pass through the like parallel to the principal axis. Therefore the next light ray has to pass through the principal focus. So now what is going to happen now? So since the light ray is passing through the principal axis, apply the second rule. Now the reflected light ray has to pass parallel to the principal axis. Now both are meeting at a point, so that is exactly going to be at C only. Therefore the image is formed at C. And what about the nature of the image, children? Here it is real and inverted. And what happened to the size of the image? Is exactly the same size as that of the object. So therefore if the object is at C, image is going to be formed at C, and it is going to be real and inverted, and it is of same size as that of the object. Now let us see the fourth condition. If suppose the object is between C and F, then the image is going to be formed. Let us see how the image is going to be formed. As I've said, the light ray has to pass parallel to the principal axis. That means the next light ray has to pass through the principal focus. Then what did I say? One more line is a compulsory line where the light ray has to pass through the center of curvature. So now I'll consider a line which is passing through the center of curvature. I'll extend that so that it will meet on the other side. So now both the center of curvature line and the principal focus line, both are meeting at a point. It is forming an image. Remember, this image formed is beyond C. And what about the nature of the image? Real and inverted. And what about the size of the image now? Size is enlarged. Okay, this is about the object which is placed between C and F. Okay, now the fifth condition is when the object is exactly at the principal focus. Now also, what is the condition I am going to consider? Let the light ray has to pass parallel to the principal uh, axis. Then what is the next condition? It has to merge. Okay, the next line has to be through the center of curvature. So let us extend that line. Now after the light gets reflected, since it is parallel to the principal axis, it has to pass through the principal focus. Just observe the two reflected light rays. They are not meeting, isn't it? That means they are going to meet. So let us assume at infinity. That means the image is formed but at infinity. Okay, what about the nature of the image? The nature of the image is real and inverted, and size is highly enlarged. For this case, I can take the example of sun. Okay, so you might have observed one of the activity in the 8th standard, children, where you have a concave mirror, and if you just hold it towards the light rays of the sun, and just beneath that if you hold a piece of paper, after few minutes the paper starts burning. Okay, the paper will form the sun rays, and you can just observe the spot of the sun on the piece of paper. That you might have imagined how big the sun is, isn't it? That you can bring it in a piece of paper. If you just prolong that converging of the light rays through the concave mirror, then the paper start burns. Okay, that means you can give that example for the case when the object is at F. Therefore, I can say the position of the image is at infinity, and the image formed is a real and inverted image. Okay. Now, let us see the last condition, that is the sixth condition, when the object is placed between P and F. So, here also, what is the condition? A light ray has to pass through the parallel to the principal axis, and one of the light ray has to pass through the center of curvature. So once it is parallel to the principal axis, it has to pass through the principal focus. Now both the light rays are not meeting, isn't it? Now we will extend that in the opposite direction. Both are meeting, but it is behind the mirror. Okay, and just observe the nature of the image. The image is erect. Erect means it is virtual, as I have said. Since it is behind the mirror, it is a virtual image. It cannot be caught on the screen. What about the size of the image? Image size is enlarged. Okay, this is the six conditions we are going to learn about the concave mirror. Now, what is the use of studying all these ray diagrams about the concave mirror? Where do we use such mirrors? We have the uses here, children. It will be used in torches, searchlights, and vehicles' headlights to get the powerful parallel beam of light. And the second use you can observe in the using the dentist. Dentists usually use a concave mirror to see the large image of the teeth, and also even in the salons you can observe for shaving usually they'll use this concave mirror. And also solar furnace uses the solar energy, isn't it? So it need to converge the light rays, therefore they use concave mirror, which is also called as a converging mirror. Now, let us see about the convex mirror, children. Let us know about the rules to make the ray diagram. Here we have the same four rules. A ray which is parallel to the principal axis has to diverge from the principal focus. What is the difference between convex and concave? Concave was converging, convex is diverging. That's all. If you just observe a light ray which is parallel to the principal axis, then the reflected ray will be in such condition that it is diverging from the principal focus. If we are just observe, this is my eyesight, then if I just observe from this point of view, then the light ray is diverging from the principal focus. What is the second condition? A ray is directed towards the focus of the convex mirror will parallel to the principal axis. If I consider a light ray which is being directed as if it is directed towards the principal focus, but beforehand, before it is going to reach the principal focus, it gets diverged. Okay, in such a condition that the diverged ray is parallel to the principal axis, that is a second condition. Third condition is a ray is directed towards the center of curvature is reflected back on the same path. If I just extend this line so as to meet the center of curvature, then both the incident ray and the reflected ray which will be in the same path of the line. And the fourth condition is wherever the incident ray it will fall on the pole of the mirror, okay, then the reflected ray will be in such a condition that angle of incidence is equal to angle of reflection. These are the four rules you need to remember while drawing the ray diagram for convex mirror, children. Now let us know about the ray diagrams. The first condition is when the object is placed at infinity. As I have said, this is a very good example. So for a image which is at infinity, okay, now all the light rays are coming from at infinite point. Okay, now all these light rays will fall on the reflecting surface of the convex mirror. After that, apply the first condition. Wherever it is parallel to the principal axis, it has to diverge in such a condition so that it will be emerging from the principal focus. Therefore, all the light rays get diverged. When you just extend that towards the opposite side, then you're going to get that all these light rays are diverged from a point. That point is the image formation. Okay, so therefore the image is formed at F, that is a principal focus, and the nature of the image is virtual and it is erect. And what about the size of the image? It is point size. Okay, this is the condition for the convex mirror. And observe one of the most interesting point, children. Here I am using convex mirror. Earlier the reflecting surface was inward, therefore so I have got the principal focus and the center of curvature towards the left hand side. But now since the reflecting surface is outward, I have the principal focus and the center of curvature towards the right hand side. So or you can just remember the way in which you can complete a circle with that of the spherical mirror. So there lies the center of curvature and the principal focus. Okay, now let us see about the second condition when the object is between the principal pole and the infinity. Now I have an object, a ray of light is passing which is parallel to the principal axis. Therefore the light ray has to diverge such that it is coming from the principal focus. Now after that, a light ray will fall from the center of curvature. Remember, from the center of curvature means both the reflected ray as well as the incident ray are on the same line, okay, or same path. Now both this line, okay, are going to meet at a point. So here I have marked that point as a image formation. So therefore, where the image is formed, the image is formed between the pole of the mirror and the principal focus. What about the nature of the image? The nature of the image is virtual and it is erect. Size of the image is, it is, when compared to that of the object, it is smaller. Now here we have studied the two cases with that of the convex mirror. So earlier case I had the object which is placed at infinity, and here next case it is between the pole of the mirror and the infinity. So remember, both the cases we have a virtual image and a erect image. Okay, now the very important question which will be asked in almost all the exams is why the rear view mirrors of a vehicle have a convex mirror. Give reasons. The very important reason for this is it always give erect and diminished image, and the second point is it have wider field of view. What is this wider field of view? Here I have a picture, children. So this like a box like picture is a plane mirror, okay, and this part, another picture I have is a convex mirror. Just observe the convex mirror, how wide the area is, whereas the plane mirror has a smaller area, that is field view area. When compared to that of the plane mirror, convex mirror has a higher field view area, therefore so it gives the wider image path. And also, when you just observe in the rear view mirror, the vehicle which is coming behind you will be always looking like erect and it is diminished. How much ever the bigger is the object is, it will just concentrate on the smaller mirror. So therefore these are the two reasons what you need to write, so even for the exams, children. So the first reason is it always gives a erect and diminished image. The second is it have the wider field of view, okay. And also, so we have another important use, that is used at blind turns and on the point of merging traffic to facilitate the vision of both side traffic. So usually even in Mysore we have this kind of facility, that is near the DC office, okay. So that is here, if suppose I have like this type of roads, so that is both the roads are meeting at a point, then so on this part, so here, so the convex mirrors are being fixed so that on either side view vehicle is coming, that means the opposite side person, riding person, can view that which vehicle is coming on the opposite side, so that it will avoid the accidents. And the third use of the convex mirror is it is used in the shops as a security mirrors. You must have visited many of the malls, isn't it? So almost all the multi storage facility shops are having the security mirror as a convex mirrors. And so this gives the clear cut image of the concave mirror and convex mirror. Now let us know about the sign convention of these mirrors, whether it is a convex mirror or a concave mirror. Okay, so now here I have divided according to the pole of the mirror as a center, then the left side and the right side. Always we consider the object is always placed towards the left hand side, whether it is a concave mirror or a convex mirror. Then, so if I consider the object towards the left hand side, the image may be towards the right or towards the left. It depends on the condition. Now, if I just consider this line which is passing through the pole of the mirror, then the distance which is measured from the pole of the mirror towards the object is called as the object distance. So, if it is from left to right, we have to consider the sign as positive, and if it is from right to left, then the sign convention, that is to be taken as negative. The distance of the object from that of the pole of the mirror is known as object distance. The distance of the image from the pole of the mirror is the image distance. If you start from left to right, it is positive. If it is from right to left, it is negative. And always remember, so that is the object. So if I consider the principal axis, if the object is placed above the principal axis, always the object will be placed above the principal axis, and the height of the object is always taken as positive. Image can be above the principal axis or below it. So therefore, so the below region than that of the principal axis is to be taken as negative. These are the sign conventions that you need to remember, children. Distances, if it is from left to right, positive, or from right to left, it is negative. Height above the principal axis, positive, below the principal axis, negative. So you need to remember, so to learn about the mirror formula, it is very very important, children. The mirror formula says 1 over v plus 1 over u is equal to 1 over f, where v is the image distance, u is the object distance, f is the focal length. Along with this mirror formula, you need to learn about the magnification of the spherical mirrors. It is nothing but magnification can be defined as the ratio of the height of the image to that of the height of the object. If I represent the magnification of spherical mirror with a small letter m, that is equal to height of image by height of object. Height of image is represented as h dash and height of object is represented by small letter h. It is also known as, so m is equal to minus v by u, that is minus of image distance by object distance. So when I consider this two as equation 1 and 2, I can combine equation 1 and 2 and I can write m is equal to minus v by u, that is equal to h dash by h. So therefore the magnification can be calculated depending on the height of the image and object or depending on the distance of the image and object. So the magnification gives exactly the size of the image. If the magnification is more, then it gives whether the image is enlarged. If it is less, it gives the image is diminished. Depending on that, we will come to know the size of the image. So this will give the clear image of today's topic, children. I hope you have understood today's class. So once again, learn all those ray diagrams with all the cases. Usually those ray diagrams, so along with the nature, size and position of the images will be asked for the exam. It is very very important. So from today, start practicing all those ray diagrams and we are going to meet again with the new concept, that is lens. Okay. So until then, take care, stay at home and have a nice day. Thank you, children.